So now let's actually get to some problems that start applying some of this SOHCAHTOA stuff in right triangle trig here in section 1. First part of section 1, part A, is you're going to just be finding trig ratios and using your calculators basically. And calculators, scientific calculators, graphing calculators, have these trig ratios kind of programmed in to them for the ratio of the sides based on the definition of each. So if we look at number 1, it says find the sine of 75. So on your calculator, and I'm going to make this a little bit bigger here, on your calculator, it's very key that you want to make sure you're in degree mode. Okay, now on the scientific calculators, you want to look for a little DEG at the bottom of your display screen or whatever, especially with the graphing calculators like TI-84s. Make sure you're in degree mode. If you hit the mode button, about the third or fourth one down, you're going to see radians or degrees. And you want to make sure that degree is highlighted. If not, arrow over to it, hit degree, hit enter. Because it will, if you're in radian mode, you will get incorrect answers for all of these. So making sure you're in degree mode is key. Again, scientific calculators are kind of defaulted to that. You don't have to worry about being in radian mode too much on those. Just make sure you're in that DEG on the bottom. So what I want to do is I want to enter in my calculator sine of 75. So if I go through and do this on my calculator, find your sine button, which is the SIN button, hit the sine. It's going to give you a parenthesis, and then you want to put in 75 inside there. And then you want to hit equals. And it says round answers. If you notice, let me make this a little smaller again. It says to the nearest 10,000th, that is 4 decimal places. So 4 decimal places. So if I go through, and I did this, I can't actually show you on the calculator here as I'm writing on the interactive whiteboard, but if you do that, it's approximately, and I would go 9, 6, 5, 9, and go to one more place, which is a 2. And you need to kind of look at this place to see, does this number right here round up or stay the same? And if that's 5 or if this is 5 or greater, it would round up. Well, it's a 2, so it would be approximately 0.9659. Okay, so now let's go down and apply some of this. Find the value of a trig function. Okay, in number 7. Now notice you have a right triangle right here, and they're asking for the cosine of theta. Remember, this is that theta symbol that's used a lot for angle measure when we get to some of this trig stuff. So first thing is we locate where angle theta is, which is up here. And notice in your right triangle, I only know 2 of the sides. I know this side and this side. Those are both legs of the triangle. Remember, this is the hypotenuse over here. Okay, so cosine, definition of cosine, so the cosine of theta is adjacent over hypotenuse. If you think of SOHCAHTOA. So we want adjacent over hypotenuse. That's the definition of cosine. Now, this would be, if I'm up at this angle right here, this would be the adjacent side. This would be the opposite side. Notice I don't know the hypotenuse, so you're going to have to go back to some prior knowledge in math. When you know 2 sides in a right triangle, how to find the third side is you use Pythagorean theorem. And I'm just going to do some abbreviating here. So notice I know my 2 legs. Pythagorean theorem says 1 leg squared, which would be 9 squared, plus the other leg squared, 12 squared, equals, and I'm going to call it x. Okay, I don't like to use a, b, and c. I like to use an x for my unknown side. So it's x squared. So 81 is equal, or plus 144 is equal to x squared. If I add those 2 together, I get 225 is equal to x squared. If I take the square root, both sides, x equals, and we don't need a positive and negative because we're dealing with length in a triangle, but that would be 15. So 225 is a perfect square. If it's not a perfect square, you got to simplify the radical, leave it in radical form. No decimals, because I want exact values of trig functions here. So leave them in simplified radical form if need be. Okay, so this side is 15. That means the cosine of theta is equal to the adjacent, which is 12, over the hypotenuse 15. And we need to reduce that. 3 goes into the 12 4 times and into the 15 5 times. So the cosine of theta is 4 over 5. Now, we'll go further in this section, and we're going to then be able to figure out, and you can use those ratios to, and the inverse function on your calculator to actually find angle theta, but we're not going to get into that on this particular problem. Just simplified fractions, make sure there's no radicals in denominators.